So here we are with question 6. All right, on question 6, you have 5 liters, and you can change it to moles by using PV equals nRT, and then you can do the mole ratios, and you can change it back into volumes of oxygen using PV equals nRT. But you're going to find yourself kind of doing the same thing twice. So I'm going to go into a little explanation about why you need to change it into moles in the first place. So remember, in stoichiometry, the first thing you do is change something to moles. But the reason you do that is because chemical equations tell you relationships between numbers of things. Now we know that equal volumes of gases contain equal numbers of molecules. So if I have 5 liters of NO, that's the same number of molecules that I have of oxygen and nitrogen dioxide. So 5 liters at these same conditions of temperature and pressure all will contain the same number of molecules no matter what gas we're talking about. Therefore, you don't really need to change it to moles. So if you're doing a volume-volume problem where you've got a volume and you're changing to a volume and the temperature and pressure don't change, they stay the same, doesn't say anything about them changing, then we don't need to change the moles. We can just take a liter ratio. So we'd have 5 liters of NO, and then you multiply by the mole ratio between oxygen and NO. And since it's a volume problem, you don't need to change liters to moles. So you just multiply by 5 liters of NO times 1 O2 for every 2 NOs, and you end up with 2.5 liters. So no need to change the moles because a liter is a set number of molecules as long as temperature and pressure don't change. Number 7, density is one of those extension problems I gave you in class today on PV equals nRT. So rearrange the PV equals mass over molecular weight RT equation into the density format. Density is mass divided by volume. So use some algebra rearrangement and set it up so that you have mass over volume on one side and everything else on the other side. This problem, number 8, is a straightforward combined gas law problem like V1, V2, T1, T2, and so on. So temperature is increasing. Just use your formula on that, or if you want to think about it, temperature increases, volume increases. So you need a ratio bigger than 1 for temperature. Pressure goes down, volume goes up, so you need a ratio bigger than 1 for pressure. Remember that the temperature must be changed to Kelvin. All of these require change to Kelvin. Number 9, same kind of problem. You can use your formula like we did in class on Tuesday, or you can think your way through it. You have the first pressure is 50, so you go from 4 liters to 2 liters, so volume goes down, so pressure goes up, so you'd multiply by 4 over 2. And then you have temperature at 25 going to 50, so temperature goes up, pressure would go up, you multiply by 50 over 25, except that you have to change it to Kelvin. Number 10, same kind of logic, use the formula, V1 P1 over T1 equals V2 P2 over T2, or you can use that, you can think your way through it. This one is a PV equals nRT problem, so it's pretty straightforward. This one is a relative rate of diffusion, so R1 to R2 is equal to the square root of mass 2 over mass 1. Use the formula that you saw in that other video that I showed previous, the previous video about the Graham's law formula. And I'm going to stop here, come back in a minute and make the last couple and talk about the last couple problems.